What challenges are involved in integrating renewable energy into the grid? The integration of renewable energy into the power grid is a hot topic right now. With the increasing focus on sustainability, many are asking, what challenges do we face in making this transition? This question is particularly relevant as countries around the world aim to reduce carbon emissions and relying more on renewable sources like solar and wind. Just yesterday, industry experts gathered to discuss these pressing issues at a major conference, highlighting the importance of finding solutions. One major challenge is the variable and intermittent nature of renewable energy sources. Wind and solar do not always generate electricity when it is needed. This can lead to mismatches between supply and demand, causing instability in the grid. Engineers are working hard to find ways to manage this variability effectively. Another challenge is power quality. Renewable energy generation, especially from sources that use inverters, can cause fluctuations in voltage and frequency. Engineers must design systems that keep these parameters within safe limits. This becomes even more important as more renewable sources connect to the grid, replacing traditional generators that provide natural stability. Grid stability is also a concern. Traditional power plants use rotating machines that provide inertia, helping the grid stay stable during disturbances. Renewable sources often lack this inertia, making it harder to maintain frequency and voltage during sudden changes in load. Energy storage solutions, like batteries, can help balance supply and demand. However, integrating these storage systems into grid control strategies presents its own challenges. Without adequate storage, large amounts of renewable energy can lead to instability when supply fluctuates. Interoperability and cybersecurity are critical as well. With more devices connecting to the grid, engineers must ensure that different technologies work together safely and securely. Smart grid technologies can help manage these interactions, but they also introduce new risks. Regulatory and policy frameworks can either support or hinder the integration of renewable energy. Engineers often face gaps in standards or outdated rules that do not keep up with new technologies. For example, grid-forming inverters are moving from experimental stages to practical use but face regulatory hurdles. Finally, the physical and digital infrastructure needs upgrades. This includes modernizing control centers, substations, and communication networks to support real-time monitoring and management of the grid. In summary, integrating renewable energy into the grid involves tackling issues related to variability, power quality, stability, storage, interoperability, cybersecurity, regulation, and infrastructure upgrades. Electrical engineers are at the forefront of addressing these challenges to ensure a reliable and sustainable power system.